Hey everybody, decided to make an answer key of the formative. So this way you can get an explanation of what you missed. Please feel free to fast forward to the problems that you got points taken off on. All right, so first off, this is identify an example, meaning that you only need to show one example. Be careful, I would only show one because some of you showed more than one and you gave me one of your answers is wrong, so you get no credit for that. All right, so a radius. There are three radius here, AC, CB, and CD. So any of those work as an answer. Next one, tangent. This is your tangent right here. Oops, your tangent right here. It hits the circle only once, and that's line ED. Some of you forgot your arrows on your answer. Next one right below that, name a minor arc. A minor arc is an arc that's less than 180 degrees, so less than a semicircle. So you could have the answer of AB, arc AB that is, or arc BD. So if you did arc AB, your answer would be written as arc AB. Some of you included C. C is not on the circle. We don't include that in an arc name. Okay, next one, the diameter. I don't think anyone got the diameter wrong. It's AD. Or DA. Next one, a central angle. There are two central angles. So you can, that's where the vertex is the center. So you can say this angle right here, which is angle BCD. Or you can say this angle, which also has a vertex at the center, angle ACB. Some of you just called it angle C. Realize that there are many angle C's and some of them aren't central angles. So for example, this right here is not a central angle. So therefore you want to make sure you're being specific. Next, a major arc. A major arc is more than 180 degrees. Some of you gave me this semicircle right here instead of as AD. That's exactly 180 degrees. So I want to go from one point to the next and name a arc. So this arc right here, A goes through D, B. That's just a sample answer. There's more than one answer. Next, a chord. Most of you picked the same chord, this chord right here, which is AB, but AD is technically also a chord. I accepted either answer, but chord AB, which is a segment. Last in this section, an inscribed angle, that is an angle with the vertex on the circle. So this is just an example of one right here, angle BAD. The vertex had to be on the circle. Okay, next one, graphing the circle. Your center, 1, -2. This is r squared, so r is 3. Graph 1, -2, and then right 3, left 3, up 3, down 3. Okay. All right, next one. Find the measures of all the angles and arcs in the diagram. So I'm just going to start finding angles and arcs that I know. So first off, I see that there's this central angle right here, which is 34. So I know that the arc it makes is exactly the same, so this is also 34 degrees. It's not labeled, but I might need it. All right, next one, I'm going to get angle A. Notice that this is a semicircle or a straight line, which is 180 degrees. So I'm going to do 180 minus 34, and I get that angle A is 146 degrees. It's also one of the things I'm looking for, so I can put right here 146 degrees. Okay, now I'm going to get B because it's coming next in the alphabet. I might as well do it. So this is arc B right here. What you should notice is that this right here is a semicircle. And I already know part of it is 73. So if I do 180 minus 73, I get 107. So now I know arc B is 107 degrees. All right, arc C is the last arc left in the circle, so there's several ways to do this. You could add up all of these arcs. and subtract it from 360. Or a little bit of an easier method is that this right here is a semicircle. So these 3 arcs have to add to 180. So I can add 34 and 42. 76, and then do 180 minus that, which is 104. So this arc right here, 104. The last arc, or sorry, the last thing I asked you for was an angle D. I'm going to highlight this in blue here. So angle D is right here. If you look at it, it's an inscribed angle because its vertex is on the circle. An inscribed angle is half the measure of the intercepted arc. So if you look at the intercepted arc, this is the intercepted arc. 34 plus 104 is 138. So I have to take half of that. Half of 138 is 69 degrees. I forgot to fill in C here. Where is that? 104. Many of you found the other angles. That is absolutely great practice. So good job. Okay, next, this entire section says round your answer to the nearest, hundredth, or sorry, thousandth. So make sure you're putting 3 decimal places on all answers. Some of you didn't show work here and then got a wrong answer and missed all the points. So make sure, I need to see what you're typing in your calculator. So arc length formula is 2 times pi times the radius. I can see the radius is 5 times 77 over 360. I'm going to go ahead and put that in my calculator. If you have this right and the answer wrong, go ahead, pause the video, put it in your calculator. 3 decimal places, 6.720 units. This is length, centimeters. Next one, area of the shaded sector. Area of a shaded sector, pi times radius squared, 5 squared, times the area of that sector, or sorry, the measure of that sector, divided by 360. All right, I want the answer round to the nearest thousand, so I'm going to put this whole thing in my calculator here. If you got the answer wrong, please pause the video and type it in yourself. You should have 16.799. This is area, so centimeters squared. All right, last one, area of the non-shaded sector, pi times the radius, which is 5 squared. Now I need the measure of that angle. So the non-shaded sector here is this angle. So I have to do 360 minus 77, and I get that this is 283 degrees. So 283 goes right here. Put that in your calculator, and you get 61.741 centimeters squared. Okay, on to the last page. So this problem here, there's definitely more than one way to do it. I'm going to show you 2 ways. The first way being the easiest way, which I'm hoping that those of you that did it the harder way will not do it a difficult way next time. Okay, so this one says that AB is tangent to the circle at point A. So I have a right angle right here, therefore I have a right triangle. Find the requested information, round the angle to the nearest tenth. So I need to find DB. So DB is this right here. I need to find that. Okay, notice I put a question mark and not an X for just a second so we can think about it. All right, so I'm going to look at this right triangle. Do I know this? Yes, it's 12. Do I know this leg? Yes, it's 5. Some of you put X there. That's not X, that's 5. It's the same as this radius. Do I know this right here? No, so we'll call that X. So this is the fastest way to do it. It's calling that whole side X right there, the whole hypotenuse. 5 squared plus 12 squared equals X squared. 25 plus 144 equals X squared. 169 equals X squared. Square root to solve. You don't have to do plus or minus because it's a length. And you get 13 centimeters. Now, this whole thing is 13 centimeters. So to get just this part right here, I'm going to do 13 minus 5. My final answer is 8 centimeters. All right, so I want to just really quickly show you that some of you did this, and I want to show you where you went, like where you made your mistakes here. So if you did it a different way, you can watch this too. But I would prefer that you didn't do this way because it's much harder. All right, so just the math is 5 squared plus 12 squared equals, and then this, a few of you called x plus 5, which is not wrong. But then you made mistakes in your algebra. So this is 25 plus 144 equals x plus 5 times x plus 5. FOILed that out, you have 169 is equal to x squared plus 5x plus 5x plus 25. So 169 equals x squared plus 10x plus 25. So here's where a few of you made mistakes. You decided to subtract 25 from both sides and then divide by 2. You're doing some weird math. This is a quadratic. It has an x squared and an x. If it has an x squared and an x, I want to try to factor it. In order to try to factor it, it has to be equal to 0. So subtract 169 from both sides. 0 equals x squared plus 10x minus 144. Factor. Two numbers that multiply to give you 144 and add to give you 10, 18, and negative 8. 0 equals x plus 18 times x minus 8. Set each factor equal to 0 and solve. You get x equals negative 18, x equals 8. If you look at our figure, this can't be negative 18, so it's just x equals 8. But make sure you put centimeters on your answer. Notice, so much more math to do it this way. So I would not suggest doing it that way. All right, next you have to find angle C. So this angle right here, this is a right triangle, so use SOHCAHTOA. Most of you use the same two pieces that I would. Let me change colors here. This piece right here, which is the adjacent side. And then this piece right here, which is the opposite side. So use tangent. Tangent of C equals opposite, which is 12, over adjacent, which is 5, and then tangent inverse both sides. I don't like where I put that. Cut. Okay, so now I'm going to put this in my calculator. And I get the angle is 67.4 degrees. All right, last but not least, let's go through this problem that you guys love. Just kidding. I know you all hate them. Definitely true, maybe true, definitely false. Okay, classify each of the following in the appropriate category. So the first one is angle C and arc AD have the same measure. So angle C and arc AD have the same measure. So if you find angle C, there is only one angle C right here. And then arc AD, they have the same measure. That is a central angle and its arc. They will always have the same measure. That's definitely true. Okay, next one. AD is equal to CD. Okay, so what you have to know here is that what do we have here? So I know that AC and CD are radii. So those are definitely congruent, those two that are marked in purple there. But what about the two red ones? So my question is when I have an isosceles triangle, does this side always have to be congruent to it? No, right? It can be, but it doesn't have to be. So that is a maybe true. It's not necessarily true, but it's not definitely true for sure. All right, next one. Oh, that was C, my bad. Let me go back here. That was C, maybe true. All right. So I started to go in the wrong order, so I'm going to keep going this way. Angle B is half the measure of arc AD. Or sorry, yes, arc AD. So here's angle B. Get rid of all these things I highlighted already. Here's angle B. It's half the measure of arc AD, which is right here. All right, in order for an angle to be half the measure of its arc, it has to be an inscribed angle. Is this an inscribed angle? Nope. It's not on the circle, so that's definitely false. All right, let's move. Oh, that's not B. What's going on? That is E. Confusing myself because I'm going this way. All right, let's move on to B now. I'm going to erase everything over here. AD is the same length as arc AD. All right, so here's segment AD. And here is arc AD. All right, think about a race between two people who run at the exact same speed. If they start at A, who's going to get to D first? The person in red, right? The shortest distance between 2 points is a straight line. So segment AD is shorter than arc AD. So the question are they the same length? Absolutely not. Definitely false. Okay. Next one, angle CAB is a right angle. CAB. That's a tangent line and a radius. Definitely true. Last one, angle CAD. Get this all out of here. Angle CAD is congruent to, or equal to, my bad, angle CDA. So they're asking, is this angle congruent to this angle? Well, it goes back to the fact that we know that these two pieces are congruent. That's an isosceles triangle. Are base angles always congruent in an isosceles triangle? Yes. So that is definitely true. F. All right, hopefully that helped you out. Go ahead and get started on, go ahead and